Welcome everybody to today's webinar. It is mass timber, the oldest, newest building material. My name is Jessica and I am the trade show and event manager for the Western Retail Lumber Association. And I'm also going to be your host and facilitator for questions today with Andre. So before I start, I really want to start by thanking today's webinar sponsor, Axio. Axio is really proud to sponsor today's webinar. They offer software solutions to support the building material centers and hardware stores in their daily operations, and they currently serve more than 1,000 businesses across Canada. And we're going to do a quick video to talk a little bit about their Ogasis solution, how that can help optimize your business efficiency. I'm going to quickly there, and we're going to get going here. Awesome. Well, thank you again to Axio for sponsoring. So before I introduce our speaker, I do want to just remind everybody about our normal housekeeping rules. Everybody is muted and we can't hear or see you, but you do have the ability to chat to myself or Andre during the session, which is using the Q&A feature or the chat function, which is below. I also want to welcome Andre, who has spent his career in the wood business, starting on site as a carpenter, to the manager of business development at Western Rib, which is a glulam manufacturer. I hope I said that right, Andre. He's passionate about building in wood and always has a project in progress in his home workshop, usually with some parts being glulam. All right, Andre, I'm going to turn that over to you. You just need to show us you're showing us your notes version too. So if you want to show us your other version.
Okay. And just going to stop that, and I'm going to. This is the one you want. How does that look?
All right, that looks perfect. Okay, I'm going to turn my video off, my sound off, but I am still here and I'm monitoring the Q&A for you.
Excellent. Okay, thank you all for coming today. This is the WRLA, of course, as a company, Western Rib. We know the organization well. When we did a lot of the arch ribs in the day for agricultural buildings, we were very involved with almost all the commercial or the lumber retailers across Western Canada. So good to be back, so to speak. And like Jessica said, if you have questions, we will be we'll throw those in the chat box, and we'll get to them at the end. So bit of an agenda. It's a bit loose as to how what we're going to talk about. The last point, what's in it for WRLA members? I'm going to cover that as we go through, just what I think, how you guys are going to benefit from it, and what you can see going forward. So quick definition about mass timber. There's some, it's a bit of an interesting one. Mass timber is really heavy timber, but they've sort of, for marketing, they've called it mass timber, I guess. And It's typically a group of materials that with solid wood panels that have the higher fire resistance rating we're going to talk about. But some of the 3-letter acronyms to them: CLT, GLT. It's a cross laminated timber, glue laminated timber, where that's the one we do and know about best. NLT, DLT, and I'm sure there's some other LTs coming soon that will be in the world of mass timber. So by definition, glulam, stress-rated engineered wood product, and all of the laminated glue laminated materials are all fall under CSA. The ones that are mechanically laminated, i.e. NLT or DLT, they do not necessarily fall under CSA standards for manufacturing. Not that that's a bad thing, it's just a different because ours is processed, it has to have quality control checks to be sure that it's made the way it's supposed to be made. So what kind of a major change that most of you will have heard of, or that is in the proposal stage, depending on which province you're in? Alberta adopted it early. BC has adopted it in certain jurisdictions in the National Building Code, but it made mass timber go to 12 stories or rather heavy timber go to 12 stories. And these are some of the sizes that you see, and I just threw it up there out of I'm sure you're not supposed to do this with the building code. Don't tell those people that I did this, but it gives you an idea. It's basically bigger pieces of wood that are allowed to be used to go higher, do their fire resistance rating. And we're going to talk about that a little further in the presentation. But here's a mass timber project underway. They're mass timber, they're big pieces of wood. This is just west of Edmonton, where I'm located. We have quick commercial. We have 2 manufacturing facilities, one in Manitoba and one in Alberta. And what we make is glulam. That's all we make. And that's what I'm going to talk about mostly today. So as a manufacturer, and this process remains similar for many of the mass timber products. All the materials graded. It's depending on it. It may be finger jointed. This is the glulam example I'm giving you. The face bonding, and then the testing that I was talking about. There's kind of 4 or 5 depending on which side of the border we're working on as to how many actual tests for the product are involved. So how do we get here? What's going on? What's changed? What's new in this wood world? And, this is an interesting picture. This was our plant foreman from many years ago, Robert Schneebacher. All our stuff used to be done manually with power saws and hand tools. Now it's moved to more of this big style. You can't even see the machinery inside of it very well. I'm going to show you another picture of it lately, but gantry style CNC manufacturing that really has changed how we do things in a big way. So I'm going to try and run this video. I apologize if it's a bit jerky. It actually operates pretty smoothly, but this is the kind of stuff that it spends its day doing, making sawdust and wood chips. So it's got all kinds of little things it can do that process the wood in really, really cool and interesting ways. This is, believe it or not, this is a bit of an older school CNC processing machine called the K2. Some of you, if you have truss plants, you'd know the K2 or the Hundiger Corporation for some of your other cutting. This one incorporates a lot more of the, the milling and the drilling that we do. And I was in the shop the other day and I came across, they had these tools out for sharpening. So I thought, oh, this is so cool. Drills and grinders and routers and all this stuff that machinery that I showed you, it reaches up and grabs a tool, one of these that I'm showing you, and does a cut or a drill or a mill. And yeah, it does some amazing stuff that would have been difficult to do economically years ago. Now, if the CNC can do it, it'll get done, and it gets done right. So the 4th industrial revolution, they call it, with robotics, it's on its way. It's made its way to the wood industry too. This one is actually up and operating in our plant. It uses all the tools I just showed you on the end of its spindle. And these can come in a number of different sizes, but it's changed how we manufacture and how we process what we do, how we do it. Some of the other things we're looking at now is how do we get hangers installed with this piece of machinery in an efficient and effective manner. But the overall effect with the CNC technology is that it's changed how we do things, and it's changed what options are available. These types of really high precision connections that were, had come on the market demanded that as a manufacturer, our precision got really high, and we had to adapt because they were getting specified. You can't do it with hand tools anymore. It has to be done with a CNC for accuracy within 2 millimeters. And by and large, if it's programmed correctly, that comes off the machine accurately, 99 point something % of the time. It's really fascinating. So this is not a project we did, but I always like throwing this up because it's such a cool project in Spain. But it just lets you know, it gives you an example of what can be done in mass timber given technology, right? This would have been very difficult without some of the tools we have today. Not impossible, but difficult. And today it's not commonplace, this style or this budget, but can be done. So why wood? What's going on in our world that has changed why wood is being used so much more? And this relates to not just mass timber. This is all wood products. And one of the things that we're seeing out there, and there was a whole 2-day, I think, seminar about biophilia. Something, if you don't know what biophilia is, and I didn't know before I heard the term either, and that was just recently. So basically it's our human connection to natural products, so wood, stone, things that we saw in nature that are maybe somewhat genetic in our acceptance of their look and our appreciation of the beauty of them. And we always do it ourselves. We always like a wood table or a stone table and that sort of stuff. That a natural wood products gives us that connection with nature and basically makes our environment, our working or living environment more palatable. And the studies that go with that say, well, you're more productive and you're a happier person and all that sort of stuff in a natural environment. So this is some of the message, not my message. I agree with it, but it's something that is definitely out there that is a big push. The other fantastic thing about wood mass timber is it can be built in all weather. I don't have to tell any of you that live in Canada that we build all winter. This came from a slide from somebody in the United States that I had to convince that wood can still be put up in the middle of winter. Not a problem. The other big piece is sustainability, carbon sequestering. So if we, the theory is if we have a tree and it's burnt in a forest fire or it falls over, it releases the carbon that it's captured. If we make it into something and capture that carbon, it doesn't go out into the environment and increase our carbon problem. So a bit of an expert on the situation, Dilbert, you had a chance to look at that. It makes me chuckle even still every time I read that comic. So hope you enjoyed that. So carbon sequestering, of course, we're on, often understated, we're on the edge of the boreal forest, most of us where we live. And one of the Earth's largest carbon storehouses. So we need to be wise about what we use out of that forest and how we use it and use it to the best of our human advantage. Just a little bit about glulam, small pieces, almost fence post styles, if you will, up to 150-foot arches that I'll show you another picture of those ones going down the highway. These are for a potash storage building in Saskatchewan where they all are. And so lots of diversity on what can be made. This sometimes comes as a surprise to people how big glulam can be made to. But it is, this one's 150 feet long. We just did a proposal a few years ago for 175s, and we think we could do a 175 footer as well. So maybe longer yet. So what I talked about earlier, what's changed in our industry was changed in wood. The CNC manufacturing doesn't come alone. It always comes with a model. So now almost 90% of our jobs, 99% of our jobs are done with a model. The model gives us our coding for our machinery so that we can put together a complex structure. And that's part of what has changed in our wood world. The truss manufacturers have been doing this for equally as long, and the technology has followed them as well. So this type of model, this is actually just a presentation model, but of course it dives into the details of all the connections, all the member sizes, all the finishes, and basically everything about it. We're even seeing guys on site now, they'll have a iPad and they'll have the model on it and they can visualize and see, zoom into a connection and see exactly how it's supposed to be built. And there's the product being installed. In this case, a Buddhist temple here in Edmonton. And just to give you a feel for the size of it, it was an interesting project. It was originally a steel roof that they had designed. They came in way over budget. They said, "What can you do with this? This is how much money we got." And we said, "Well, here's what we would do." And we built it in a couple of stages. You can see the truss, it's a 4-truss system, and then a cross braced, and then rafters that swoop up at those nice sort of curved angles that made up the roof, and mass timber ceiling in this case as well. In fact, glulam panels so that they could follow the curve of the roof, 300 mils wide. But the peak of that roof from top of steel to the peak was 12 meters or 40 feet. I know, isn't that tall? So prefabrication always starts with a model, but prefab needs pre-con. So pre-construction, lots of pre-con meetings, staging. You get lots of different pieces. They need to arrive at the site at the right time, in the right order, on the truck in the right sequence. So when they come off the truck, they can be put in place without wasting time with staging and that sort of stuff. Many of the sites we're involved in are in tight situations with an active street on 1 or 2 sides, no back alley access due to power lines or other reasons, and has to be very precise in terms of how we design it and the sequence that it comes off. So they're a Tudor arch, kind of a takeoff of the old arch rib building. And in this case, a riding arena. We weren't on a tight site in this case, but often we are. And their shop, so again, prefabrication. In the past, we would not have installed hangers. Now that is part of our scope, and that's part of what is expected from us as a manufacturer. When the beams arrive on site or the mass timber arrives on site, anything that can be attached is attached. In this case, you'll also notice that the beams are pre-stained to a predetermined color, which is, believe it or not, can take just as long as the modeling process by the time we get through that piece. And there's the finished building. This is just south of Calgary, a riding arena. So the other prefabrication, pre-assembly that we're seeing in this case is a 9-meter floor panel cassette, they called it. And it went so far as to have, you can notice in that connection to ultimately the connection to the beam also had a lifting hook. So when they picked it off of this truck, it already had the lifting hooks attached. They didn't have to do anything other than snap in their rigging equipment and fly it into place. What we're also seeing, and this is part of the, I'll just do a bit of a segue in the what's the value proposition for a lumberyard or a retail lumberyard. These offices we're seeing, and these are getting more common. There's 2 underway in Toronto, 1 in Vancouver, 5-story. They use a lot of wood infill, a lot of plywood, lots of other partitions can also be wood because they fall under the code for that requirement. The grid that's used on it is not always a steel type grid. We're getting them retrained on that. If it's a wood building, it's different than a steel. So the changing from a steel building to a wood building is not always the best. They'll often use a 12-meter grid, which is not as sort of not as good for wood because we end up with very tall beams that impacts the overall height of the building. But the 9-meter grid seems to be works really well for wood structures. So codes and fire. This is kind of one of the things that a big challenge with acceptance on light frame and mass timber is fire and how wood or how mass timber sort of resists fire is this theory around, not a theory, but it's actuality is the core of the member. When it burns, it chars from the outside. The charring insulates the wood and the connection, as you can see on the bottom right-hand corner, insulates the connection from heat and allows that connection to stay at a reasonable temperature that it doesn't fail. So in fact, the wood, in this case, the wood protects the steel. I know some people have a bit of a, well, wood burns in it, but yes, wood does burn, but it also protects. If you have enough wood, anybody that's gone camping has tried to light a really big piece of wood with a single match or a lighter knows that that's not how it's done. It's in small pieces and then build up to a bigger fire. But the charring effect is known, documented, and proven. And to that end, there's a 45-minute to up to a 2-hour fire resistance rating that can be achieved with glulam member, and not just glulam, CLT and other members as well. But when in the design stage, this is often a question that comes up: how am I going to design that for fire? And these are some of the solutions that come out of it. So we did on our glulam timber panels that we use for commercial projects. We actually had a fire test done on it, using it as a panel, not a beam. So it's a bit of a different application. The code didn't really address how it would perform. So if you use the prescriptive method with the building code for a 5-inch west deck, or basically a 5-inch glulam deck, it would have given you a 1-hour fire resistance rating. When we put it under load and under test that FP Innovations did for us, it actually came out as a 2-hour fire resistance rating, and the 6 7/8 a 3-hour fire resistance rating, and it was under applied load, not just sitting there on its own weight. It was proven to be much higher than the prescriptive method on that the building code uses. So GLT, glulam timber panels, one of the LTs. Kind of glulam standard sizes that's available. It's got some neat features in that you can hide a lot of the fire suppression and electrical systems up inside. With a mass timber structure, of course, you want to see that structure from underneath, so you really don't want to see all the electrical and fire suppression. So a lot of efforts are made to hide it, put it on top of the structure if possible. And sometimes it's just not possible and has to be below. But going through that extra effort does take, again, back to the pre-con, takes more time, takes more effort. You have to think about it and plan in advance. There's another project under construction. And by the way, if anybody needs to take a drink or stop and have a snack, go ahead. I'm going to do the same. So grid, sorry, this, what I meant to say about the grid earlier, they've got a proposal for budgeting coming out this spring still, I think. Better do that soon, spring's almost over. But they did a costing analysis of mass timber projects just to see show how the competitiveness of it would be in, actually it was old lumber price. So I think the delay is they're doing some updating on it, which no surprise, it's changed. So some projects I wanted to show you. This one, I gave you a bit of a glimpse on a Salt River multi-purpose building. I used that example of building in the north, or in the cold rather. This one was put up in the January of 2019, I believe. And they had some of the daytime highs when they were putting this up didn't get to above -25. So it was very cold, but they had a deadline. They had short work days and obviously short light, but they got it up in time for what their deadline was. This is sort of later on in the construction sequence. Again, for the value proposition, okay, mass timber buildings, as you can see, sheeting on the outside, 2x material for the infills, all supplied by the local supplier. So their tight deadline, it was kind of a cool building because when they say multi-purpose, it truly was a multi-purpose building. They had this sort of open recreation area. It also had a courthouse, and that was the pace that they had to get the building up and ready for a court date that somebody had in the spring, some big case. I'm not sure what it was all about, but they were very adamant that they wanted it open for, I think the date was July 15th or something like that, because they wanted this nefarious criminal put behind bars, and they wanted to do it in their new facility. So courthouse, the picture I'm showing you here, council chambers, a commercial kitchen, cultural space, and they actually added in some lease space as well. So kind of a cool project. those long span arches that everybody oohed and awed about when I threw the slide up. This is them in place, 220-foot clear span product storage building, and the product is for potash, of course, very corrosive. So wood is really the only material that can resist that element without coating all the steel and everything. And there is some steel involved in it that they had to go through some fairly rigorous cycles of preservation to keep it from rusting, because it is very very corrosive. But all our other connections have stainless steel and all kinds of different applications to keep it from rusting. Interesting, some of the potash storage buildings we did in the early years of Western Arch Rib in the late 60s, early 70s, they're still in use today. The methods behind it all work very well. And again, speaking a bit to, I think this is another slide I had in for that US presentation where they said you can't build like that in the winter. Well, this one took a year to put up, so yeah, you can't put it up in the winter. Bit of a higher profile. Again, this is hopefully for many of you, this is a word learning day. So we covered biophilia. That was a new word for me, and maybe I was just not schooled well. This one, a quaternary roof. And those of you that don't know, and I didn't before this project either, quaternary roof is a roof held in tension. So these members are glulam held like a rope. It doesn't have a bending component to it. It's simply tension only. And you can see by the size of the member, I believe they were 130 by 400. They were really slim, and for about 130-foot clear span, it's quite amazing. Amazing engineering behind it, and turned out really good. This was done, I think, about 4 years ago, I'd say. There's the quaternary roof members in our shop laid out and having a coating applied to them. You can see in the bottom left-hand part of the picture too, the connections were all pre-installed. So when they got to the site, the installer was able to put it together fairly quickly. And you can see from the picture, you can kind of see those splices that in this location here and that other location actually came as 3 pieces for ease of shipping or for legality of shipping, because 130 feet is pretty tough to ship into the density of Surrey where it went. But with that, the roof went up in 12 days, so pretty amazing. So 95,000 square foot roof, excuse me, double, sorry, I wanted to show you also that plywood on the roof, double layer 3/4 inch TNG for plywood. So again, where's the value for retail lumberyard? Well, that would have all been sourced through somebody. Project Spokane, Washington. I showed you this composite panel in an earlier slide. Some of the changes that you see in a mass timber building, columns going straight through rather than beam on top of the column. And that's simply a function of economics, that you want end grain for higher bearing capacity. And when you get those stacked loads, in this case, I think it was a 5 or 6 story building, then you want those accumulated loads get pretty high and you can't bear on edge grain. So just a bit of a difference, some of the different things that happen in a mass timber building. There it is under construction, the mass timber panels over to the side, ready to be flown in. And I believe this is just across the river from the university. There it is, finished building. Used CLT floors. We did not supply that part nor the walls, but we did all the glue lams and the attachment to the CLT. And there we are, Spokane finished building. So 1, 2, 3, 4, 5 story. Canada Olympic Hockey Training Facility, Calgary. This one's, I believe this one was built in 2010. So when Hockey Canada is doing their training for the Olympic teams and some of the games and other games too, it's an Olympic size rink, which is a bit rare, and some nice seating, and a bit rare for arena too, where they have glass on the outside to let in natural light. So it really is a beautiful, beautiful place to watch hockey. and curling. And this is where a lot of the tournaments were, or the bonspiels were held this winter. Every time it came on, I pointed it out to my wife. She says, I know you told me that last time, but I pointed out anyways. And this is kind of funny. To me, it's kind of funny. I seeing the virtual people in the stands. And yeah, so they hold, I think there was 3 or 4 curling bonspiels there this winter. Algonquin College, Ottawa campus. Anybody on from Ontario may be familiar with this building. This was done by our partners in Eastern Canada, Timber Systems. As is this one, Toronto Montessori School. You'll on the Canadian Wood Council website. Because it's just a beautiful building. You're going to see this one popping up often. Also, same architect that did Thunder Bay Hospital many years ago and Credit Valley Hospital, just outstanding. But speaking about biophilia earlier, he is, this Ty Farrow is all about biophilia. He says places change your mood, increase your abilities to function in a higher level. Another shot of a similar area in the building. But again, without that technology, without pre-construction, CNC technology and modeling, this would be a difficult project to get up in in an economical fashion. The school in Washington, again, this used all CLT walls, ceiling, roof, and then glulam beams, walls, columns. And of course, we've done glulams in schools for many, many years, and the popularity of that is coming back. Again, if you can get it in a wood in a school, if we can get glulam in, the other products that go for the light timber framing, the I-joists, which most schools, if they're not too large, still fall under that building code category that it can be built of wood, then a great value proposition for retailers that have the engineered wood products and light frame wood. This is an older school in Wetaskiwin. I like it because it used, I think there was 100-foot trusses, and yeah, just as a nice description of how it can be done. Of course, now we would try and convert that steel roof into a mass timber or a light frame timber ceiling roof. And this was an interesting one. This was, if any of you have been involved in an IPD project, this is an integrated project delivery system contract method where all the partners are involved in it. And so you go through a very rigorous vetting system for the material. So the material has to be the best application in the job. So with that, what the system that they landed on was 4 stories of a combination mass timber, light frame timber. And this is what it looked like under construction. So it read like a light frame timber building. You think, well, you can even go to 6 stories. They didn't need it, so they didn't use that. But at the main level, they integrated a steel transfer slab. And steel, again, or even over concrete, was chosen based on it's the best material for the system, as was the light frame timber walls that had the ability to run, this is a typical unit. So on all these corridor walls, you were able to run all the services vertically and efficiently, leaving a gap in between. And as you know, with creating a party wall or a shared wall and staggering the joists or 2 walls, you have a great ability to run services vertically, and provided they're all stacked. Of course, the owner messed that up a little bit at the main level by using a transfer slab that caused a lot of gyrations and changes at the main level, but all the units above were completely stacked. And there you see you have a student that normally would be studying, but he likes the building so much he's just out there hanging around and doing what he shouldn't be doing probably. But truthfully, they did create in this at this college, they created some really nice common spaces. Again, speaking to that biophilia, just a great place to hang out. I like to call this the Harry Potter School of Magic. It's not, it's a private school in Shawnigan Lake, Vancouver Island. But again, if it's a mass timber structure, chances are the materials around it are going to be wood too. And chances are that's going to be a good opportunity for others in the wood business. This used in a lot of different elements. not the least of which were mass timber. You can see the CLT roof, glulam beams, solid wood decking. Kind of a bit of the hilarious part about it, they did spec and put on timber, 3x6 timbers over this curved roof as well, but it was without its, not without its problems. So I think they wouldn't do that again. But again, without modeling, you can see by the complexity, the geometry of this school and community center, this would be a lot of work without that technology, and really lends itself to being able to have that flexibility and accuracy. Again, our partners in Eastern Canada, Timber Systems, put up this school in King City, Ontario. Again, all for the most part a light frame combination mass timber building that uses wood and has some just beautiful spaces to it. The EFCL Plaza Edmonton. This was really kind of an interesting project. I was just there on Sunday, in fact. And they attribute to all the community leagues in the community, in Edmonton community, that have sort of donated their time over the years. So a real nice nod by the city of Edmonton to all those volunteers and organizations that that contribute to so much to the society. They put up this pavilion. Of course, it being in Edmonton, this is a skating rink in the wintertime and a lake in the summer. So a beautiful spot. And although the rumors would have it that I flew the drone and almost crashed it at this building, it's not true. The drone flew it through here. I didn't put any of those clips in here, but there was some, let's just say there were some nervous people around that when I was flying, and probably for good reason. Another Buddhist, and we do other, we're not limited to Buddhists in terms of the religious buildings that we put up. I just happen to have the Buddhists do really cool structures. So the nice curvaceous elements that they like to add really add to the beauty of the structure, I think. And these owners are really engaged. They came to our shop and they were touching the beams and feeling the structure before it even went up. And it was kind of neat to see an owner that engaged in their building. This one in Chilliwack, BC. Fire Hall, Port Moody, BC. Also, you'll see the again, combination of wood and steel roofing. What we're seeing in the mass timber world now is they won't use steel roofing. They'll keep it all a wood building if it works out. They always like this building because they did a great example of how protecting the wood from the elements, how they pulled these beams back from the eave, so they had at least a 45-degree angle away from the last point of protection. So they'll really see a great durability to this project as the years go on. And I was like it because sometimes the biggest resistance we get with wood is with firefighters and the fire commission. So putting it in their building gets a little bit of buy-in, I think, in terms of them accepting wood. We're working on a project on Vancouver Island right now, Malahat Skywalk. This is kind of on the, as you can see, on the top of a mountain. And this goes up, I'm going to say 100 and some feet from here to just have a great view of the inlet and the area surrounding. So the Canadian Wood Council, I know it sounds like I'm doing an advertisement for them, but they put out this design options for 3- and 4-story schools in BC because their densification is getting so high. And we're seeing that to a lesser extent in our smaller cities where I live, Edmonton, Calgary, Winnipeg. You know, land is getting scarcer. They're building on old sites. They want a bigger school. So now they have to go up. So 3- and 4 stories are going to be very commonplace in BC, but I think the rest of the provinces can learn from this too, in that wood is an option for this. And this on online document, anybody can pull this off the internet. You don't have to live in BC, and gives some great options for it. So when we get into this sort of stuff, the diaphragms are often wood shear walls, other elements, light framing walls that can be done in wood as well. So great for the wood industry to have this kind of in its back pocket to promote. There it shows a bit of a cross section, and it's it's certainly not a fully developed, it's a conceptual look at it anyways, but it does give overall building heights, which is always a concern, and always one of the first questions that comes up when we're going to mass timber, because it's not the mainstream and not where it's usually used, and everybody needs some satisfaction that it's going to work out in the long run. So this project, last two projects I want to show you, they're both recreation centers, so to speak. Clayton Community Hub, Surrey, BC. This sort of epitomizes some of the complexities that come with some mass timber projects. This uses the connection type that uses precision installation, precision milling. So that connection is, as you can see, is sort of in two pieces, and then it's clamped together. So when it goes on, you'll see one piece is on the supported member, and one goes on the support member. So you can see them installed in here. This system is a reciprocal system, so you can see they've had to fully scaffold the whole project before they could release and move on to another area. And then the reciprocal system supports itself, but quite unique. No new words in this part. There they are, the pinwheels are being assembled. They were too wide from top edge to the other long side to be shipped in an economical fashion. So they were assembled on the site. But again, as I mentioned earlier, anything typically that can be done in our shop, they'll always request that it be done in our shop, or that we price it out. And it's usually accepted that it's done faster in a controlled environment rather than on a site. So there they are installed. This member carried most of the load, so it used two of those connections that I showed you a picture of earlier. A lighter loaded member, only one connection, and in fact, this uses the screws that I showed you in that picture. This just is a screwed connection that really didn't receive much load. The screws could handle that capacity fairly easily. Their aerial view, so all this reciprocal system in one main area. It did start spilling over budget at one point, so they said, well, can we just go straight beams here? And so we ended up they're changing that over from the reciprocal to these straight beams, which ultimately looks really good too. This is kind of a gym area, but the marquee area, this is the front entrance, the gathering area, the public space. They really wanted some to have this reciprocal system shown. We did these little benches down here too. There we are. The other interesting thing that is coming out that does play a big role in is passive house. So the really super insulating a building in this case, or a house. That passive house movement is definitely afoot, and wood, whether it's light frame or mass timber, of course, has those inherent natural properties of insulating that speak well to this type of a system. So expect to hear more of that if you haven't heard of it already. That's not a new word, but it is a new term out there, passive house. And this Clayton Community Hub was one of the first commercial buildings to reach passive house standards in Canada. So here we are, just to give you an idea of some of the things we need to go through on our projects. This is our project manager. It looks like Mark. He looks like he's yelling at these guys. He's not. He's talking in a calm voice. But the expectations for this project, Hayward Field, Eugene, Oregon. The owner, Phil Knight, of course, founder of Nike, had very specific requirements that they wanted to show on this project. So they went over and above. They really had a strict spec. They had strict requirements. They came to our shop and inspected wood before they came, the input materials. So the 1x material, I think these were 1x10s that we used in it. They wanted to see them, to see what they were going to get, to understand. And they had requirements after that. So here's a sample of the piece on the floor, and Mark's just giving our guys an outline of what's to be expected from this project. The next step they did a full-scale model, mock-up, and because they wanted to know how all the trades were going to interface and integrate. They were running electrical through some of this HSS, so they had to be collaborative on BIM modeling and understanding what was required of it. This whole structure was never used. That was for visualization and call it practicing on as well. And they had a special skin panel, clear skin. I forget the name of the poly something or another that goes on the exterior of this. But there they are. It was a 3-piece system, so they used a rafter, a haunch, and a leg. And you see here this. It looks like the haunch piece is being flown into maybe this side over here, but it had to go in sequence so that it was erected before the steel was threaded through the opening in the wood. So there we are, Hayward Field. This is the stadium. This is actually a rendering. And it was due to open, the building was due to open about a year ago, but of course with COVID it didn't. It's used for the US Olympic trials. And underneath this whole ring is another training facility underneath it that's completely covered from above. And of course there was no people in here till recently. It kind of sat vacant. And there we are. There you can see the vacant seats. This is not a rendering. This is the actual stadium. And that's that clear roofing that really, it's a quite stunning structure at night too. I'll show you a picture of it, but here we are again, not a rendering. This is an actual picture, no people in the stands. And our challenge was this, I'll show you in the next picture actually. The elevation of the roof changed from one corner of it to the other corner. So every piece is unique, every piece is different, 565 different pieces that had to be modeled. So quite challenging geometry. Again, needed to have that robust modeling attached to it, and details, connections, pre-con, prefabrication, all the elements were paramount for success on this project. And it turned out the construction of it went very smoothly from our side of it. Because we had done all that work, and the GCs that recognize that, certainly it pays a dividend in speed of construction later on. So that's most of what I have to present to you, except for the wooden question mark.
Awesome. Thank you.
Yeah, any of you that want to contact me, my email down at the bottom, or you can get it from Jessica as well.
Yeah, I'll send it out. We are recording this session in case anybody's wondering. So I do send out a link to the recording, and I'll provide Andre's information to everybody too. So first of all, the pictures, stunning, beautiful. I really like the Harry Potter reference. And I want to remind everybody, if you have questions, there's a chat function below or Q&A function below. I'm going to quickly jump into my chat function because I did see a question come up there. Where'd it go? Oh, it's there. Sorry, it's on my screen. Okay, so hi, Andre. Thank you for your presentation and the images of the beautiful work. I know who to go to for a Harry Potter themed structure. Okay, good. We all know who to go to now. My question pertains to the supply chain challenges experienced in the building materials supply chain. How have the material shortages impacted your ability to complete projects?
Oh yeah, hey, great question. No, I like the higher level question too. That's cool. So far, our procurement is a bit longer. We're a bit specialized in that you don't just buy what we make glulam beams out of is what we call lamb stock. So it's not, you would never find it at Home Depot. You would never find it from your brokers. And it's a bit specialized because our moisture content is lower. We want to no wane. So my point being that our mill connection is a bit different, a bit of a longer term buying process. So we did have some, and remain in contract, under contract with for supply. So we haven't been impacted by supply.
Okay. Has it impacted your ability to quote or forecast quoting on some projects? No.
No, forecasting is tricky because of pricing. And we have seen dramatic, not as probably dramatic as many of you have seen for other products, but we have seen a dramatic increase in price. Ours is about, I'd say it's just over doubled in cost. We paid a lot more for it at the beginning. You know, lamb stock is more always probably not double what you would have normally paid, but it's quite a bit more than what you would pay for normal framing lumber.
Okay, this question's from Will. Has the record high lumber prices made the mass timber projects less attractive?
Interestingly, Will, yeah. You know, the other side of it that we're seeing that's quite interesting is the short answer is yes. And it's not necessarily due to our product. It's everything. Projects are coming in. Oh, we're over budget. We need to go back to the government, to the school board to get more money. Everything. And so it's not just us. It's ceramic tiles. It's insulation, concrete, everything, rebar. The one thing that we have that is interesting with the HSS, the hollow structural steel from steel suppliers, we're seeing a lot of GCs coming to us and saying, "Can you switch this out for glulam? We know you can. We know you can make it, but we just can't get this size of HSS." And there's a few. I forget which sizes they are. They're just not available. They're not made. They're not.
Okay,
They're
so
not on the market.
the perception is that it's only lumber, but it's actually a lot of items on a large scale project that are.
Exactly, Jessica. I
Lumber
think
is just the visual front of all of this.
I heard, if anybody in the steel business is on the call, I heard open web steel joists are out by 9 months and climbing. So it's almost not even an issue about is your price more? It's can they even finish their building, right? I mean, if you don't have the joists, you can't do anything. So
Okay, got another question. Have you seen an increase in projects in the past year? Housing has increased, but curious to know if there has been an increase in infrastructure investment.
yeah, that's I haven't seen so in infrastructure, I'd say no. In private money, there's been a lot still the projects that were committed to building, i.e. some of the office projects we were involved in, they still went ahead. They saw it as we were doing one in Boston right now. They've had 2 6-story buildings that they've said, well, we see a huge future in office buildings still, which surprised me.
Yeah.
And they went for it. They're going great guns, and they've got a site, they had redevelopment site that they had, I think it was 25 acres that they're redoing, and two of the buildings are in mass timber.
Wow. Okay. That is surprising. I guess, again, you think with everything going on, it wouldn't be. So at the top of your session, you talked a little bit about changes in building codes. And I kind of wondered for our lumber retailers, how are those codes going to be impacting them, or will be, or are right now?
Yeah. So, I mean, the near recent code impact, of course, was going from 4 to 6 stories, 4 to 5 to 6. So that's been, I'm sure you've all seen some of that increase. The going to 12 is a bit of an interesting one, because now we're moving into the concrete world, right? So we never had a wood solution before that. So the proposition for the WRLA members is probably not as good in that. There will be some stuff in there in the way of probably, I would say, in sheet goods, maybe. If you deal in drywall, there's a lot of drywall that goes in there in those buildings for fire protection, because a lot of it is encapsulated wood. Light framing. So probably not as good in the 12-story. But the other part of it that the Canadian Wood Council is also working on is some of the what they call light commercial. So the footprint of light commercial buildings that can be built, as well as office buildings, moving those up so it's not alternate solutions, so that it can be done in light frame / mass timber. So there's stuff in the works, and there's stuff right now, and yeah, they're working hard on it. It's impressive.
Okay, that's great. So my next question is, you had showed a picture too with that I think it was Port Moody with the fire hall and the timber was under. How does mass timber react outside then? Was that an intentional pullback because it reacts differently outside, or?
No, that's yes, that was an intentional keeping the wood. So wood outside is still wood outside. It was not protected.
It's not magical.
No, we did not.
Okay.
This is not the Harry Potter building is different.
Right, got it. Okay.
Typically, their wood outside will react the same as regular wood outside untreated. It's gonna, without protection, it'll degrade. I mean, step one to me, pulling that like you described, having that element underneath the protection of a roof is going to be the first best step to doing it. If that can't be done, if it projects outside or is exposed, having a flashing over top or the end is the top and end are the most susceptible. Not a new word, just one I can't pronounce. Those are the most susceptible to it. Coatings also do a level of protection, but they must be maintained. And that has to be, that knowledge sort of has to transfer from builder to owner, that they need to have a program in place to protect that wood if it is exposed. So my advice is always under a roof is the best solutions, but that's not always possible either.
Okay.
Yeah.
So what coatings are used for exterior applications then?
Yeah, so yeah, a good one. Typically we'll try and have something, we'll recommend a specification of at least 3 coatings so you have a good buildup with UV. Uh, there is no coating out there that we've seen. There are people that say their clear coatings will work outside. We have not to see one yet. And if you have come across one, please send it my way. Everybody would love that, but to our knowledge, just not out there. The
Okay.
next best thing that we've come across is the SandSyn products. They seem to perform very well outside and have a nice feature in as much as to go to recoat, their finish doesn't flake off. It can be recoated without a complete sanding, unlike some of the other ones. Some of the other ones are really good. The Sick and Cetol is a really robust coating, but if you do let it go too far and it has to be stripped off, it's a bear cat of a job to get it recoated.
Okay, we have another question here. So many product lines have been impacted by raw material shortages and transport delays. I'm curious to know if all of your material is Canadian content.
All our input material is, all our
Yeah.
wood.
Mm-hmm.
I think our glue, now the glue is an interesting one. I'm not sure exactly where that comes. Ironic, there used to be a manufacturer in Edmonton, Board and Chemicals. They were taken over by somebody else. And I'm not sure exactly where that comes from, but I mean, glue makes up less than 1% of our volume of material. So no, we do all our material is 100% Canadian. All of our detailing designing is done in-house, and contractors that we use are also all Canadian. Oh, I shouldn't say that. There's some US contractors use on occasion. But I'd say the connections would be the one thing that sometimes those proprietary connections I showed
Right.
you, they're
Yeah.
sometimes European.
Oh, okay. Right.
Yeah, those big screws that we use often.
Mm-hmm.
Now we are able to get some from Simpson has a line they're coming out with. They're quite good.
Yeah.
And they're really developing that. They're seeing what the Europeans are doing, and I think they're on it. So you'll see some really cool stuff coming from Simpson, I think, in the next
Oh,
while.
okay.
But
And by that, guys, they mean Simpson Strong Tie, which is one of our members who will be at the show. So we'll ask them if they'll
oh
feature
yeah,
anything
yeah,
on
oh no,
that kind of stuff. That's right. I'll
yeah,
have
no, I
to
think
bug
Simpson
them.
has some good stuff. Yeah, and you might get them for one of your seminars. In fact, Jessica, I think they've
Yeah.
got some new stuff that you might members might not know about.
Yes. Yeah, that's great. Okay. Well, if it's for any more
Okay,
questions, we can use the chat function or the Q&A below. I don't see anything coming in.
okay.
Okay, well, I think actually we finished almost exactly on time. So I want to thank you, Andre and Western Artrib for coming and presenting to us. I wanted to take this time again to thank our sponsors, Axio, and remind everybody I did record this session. We're going to get that recording out to you along with Andre's information if you need to have a follow-up question for him. And we'll be posting this to the WRLA website, so it's always available to go back and watch it later.